Why does an X-ray see through your skin, but not your bones? You walk into a clinic. They put a lead bib over your chest. They tell you to stand still. A machine clicks, and 10 seconds later, a doctor is staring at a picture of your skeleton. How? You are mostly water. Your skin is right there in the way. Why does the X-ray not see it? The answer starts in a lab in 1895. Wilhelm Rontgen is in the dark. He turns on a vacuum tube. A screen across the room starts to glow. Light that he cannot see is somehow passing through cardboard, through wood, through his hand. He puts his wife's hand in the beam. He develops the plate, and he sees her bones, her wedding ring, floating in fog. He has no idea what this light is, so he names it X. But here is the question that took decades to answer. Why bones? In the next act, we follow that X-ray into a single atom. And the answer is not what you would guess.
Why do X-rays only stop on heavy atoms? To see what is happening, shrink down into a single bone, into a single calcium atom. That atom has electrons orbiting a nucleus. The electrons sit in shells, inner shells, outer shells. An X-ray flies in. It is a packet of pure energy. No mass, no charge, just energy moving at light speed. If the X-ray meets a light atom like water or skin, it keeps going. The electrons are too far apart. The shells are loose. The X-ray barely notices them. But a heavy atom is different. Calcium has 20 electrons packed close. The inner shells are tight. The electrons are bound by hard energy. When the X-ray slams in, an inner electron gets blasted out. The X-ray dies in the collision. Its energy is gone. This is called the photoelectric effect. Einstein won a Nobel Prize for explaining it. That entire collision is over in less than a billionth of a second, and it has happened a million times since you started this video. But here is the strange part. The atom is wounded, and what comes next is how an X-ray really builds a picture.
How does one tiny collision turn into a picture of your skeleton?
The X-ray machine does not fire one X-ray. It fires trillions every second in a beam shaped like a flashlight. That beam hits your body. Photons that meet water and skin sail clean through to the detector. The ones that meet bone get absorbed, stopped cold. Behind you, the detector counts. Where lots of photons arrive, the image is dark. Where almost none arrive, the image is bright. That is your X-ray. White means photons did not get through. Dark means they did. It is the inverse of a photograph. Your bones look bright because they blocked the most. Your skin looks dark because it blocked nothing. Your lungs are almost black because they are full of air. The whole picture is built in 1/10 of a second. Trillions of photons, billions of collisions, all assembled into one shadow. Your skeleton is the only part of you that ever shows up. Everything else is the gap. But there is one number left to talk about, the X-ray dose, and it is much smaller than people think. Stay for the math.
How small is the dose from a single X-ray? Here are the numbers. One modern dental X-ray gives you about 5 microsieverts. A chest X-ray gives you 100. A CT scan of your abdomen gives you 10,000. Compare that to a banana. One banana gives you 0.1 microsieverts of natural radiation. A dental X-ray is roughly 50 bananas. A chest X-ray is 1,000. A transatlantic flight gives you 40 microsieverts. That is more radiation than your dental scan. Living 1 year on Earth gives you 3,000 microsieverts of natural background radiation. 30,000 bananas every year just from existing. Your X-ray sits inside that everyday number, not above it, inside it. Within 1 year of Rontgen's first photo of his wife's hand, doctors were diagnosing bullets, tumors,
broken bones. 6 years later, he won the first Nobel Prize in physics, 1901. He refused to patent the discovery. He said it belonged to humanity. Today, 4 billion X-rays are taken every year. Every one of them works the same way. Heavy atoms stop the beam. Light atoms do not. A shadow gets cast on a detector, and a doctor sees inside without touching. Pretty good for an invisible light nobody understood until 1901. Would you take 1 X-ray a year for life? Yes or no? Follow MedPhys for more physics inside medicine.